Alright, so we're going to solve systems by Cramer's rule. And like I said a few minutes ago, guys, it's all review. We've already done this year. Okay, so let's just refresh your memory. The first thing I want you to do is to find the determinant. So for number one, if I give you a matrix, I don't know if you will remember or not how to find it, but there's your matrix, 3, -2, 5, 6. And the first thing, in order to solve Cramer's rule, you have to be able to find the determinant. So that's why we're studying determinants, okay? So to find the determinant, it's pretty easy. You subtract, and that's where you're gonna forget, okay? But you subtract, not add. And you start in this corner, and so you're gonna say, okay, 3 times 6 is how much? 18. And then you're going to subtract the other two numbers multiplied together. So 5 times -2 is -10. So I have 18 minus -10, which these turn to plus. So technically the determinant is 28. Okay, now let's try number 2. -2, 5, 7, 8. Okay, and number 1 actually has a typo on it. If you're asked to find the determinant, really, the question will look kind of like this. It will look like an absolute value. Okay. So to solve the determinant on this problem, same thing. You're going to go this way first. So in your head, you can say -16, always minus, right? So minus 7 times 5. So -16 minus 35, which gives us -51. So the determinant here is -51. Make sense? It's very easy. Number 3. Okay, it says the determinant of, and I'm going to give you a matrix. Okay, 8x, -9, and -3. There's your matrix. Is 21. So I'm telling you the determinant of that matrix is 21. And the question actually is to find x. So it's just basically just trying to ask if you truly understand the concept of the determinant. So the determinant of the matrix, I'll move it up so you can see better. Okay, so we're just gonna map the problem out like before. Okay, so I know you have to go this direction first. So I'm gonna say, okay, -24. We always subtract minus whatever you get here. So -9 times x is -9x. So that's going to turn to positive. Is, so equals 21. Now then, we're just going to solve for x. So add your 24 to both sides to give you 45. And then it actually just asks for x, so x is 5. Now the next part, if you have a calculator, it's going to come in handy. Because sometimes when a matrix is so huge, it's only easy to find a determinant, guys, if it's a 2 by 2. So anything bigger than that. So with no calculator, a 2 by 2, you would find the determinant by hand. Anything bigger than a 2 by 2, you're going to use a calculator. Okay? And in reality, it's much, much faster to find the determinant with no calculator with a 2 by 2 anyways, than to type the whole matrix in just to multiply 2 numbers together. All right? So I'm going to give you, it says use the calculator problem here. And you want to type or write down the steps to help you. Use the calculator to find the determinant. And here's the matrix. 1, 3, 2, -2, -1 and 1, and 3, -3, 5. To find it, here are your steps. Step 1, enter the matrix into the calculator. And for those of you that maybe weren't here for the calculator matrix lesson, okay, you can do, I want everyone in the room to do me a favor. Go to second plus 712. And that way you're not worried about the wrong matrix being in there. Second plus 712. Okay, now then, if you were absent for the matrices lesson to type in the calculator, you just go to second matrix, which is under the math key. And we are going to edit a matrix. You're going to go over to edit and hit enter. The matrix that I gave you for this lesson was a 3 by 3. So you're going to do 3 by 3. And notice the 3 by 3 matrix comes up and you just enter in all the data. Okay, once you have all the data entered in, our goal though, remember, is to come up with a determinant, right? Does everybody have it entered in? Okay. So if you were to write down the next step, step 2 is to go back to matrix. You're gonna go to matrix, you're gonna go to math, and then you're gonna go to the determinant. So matrix, math, determinant. So I'm going to go back to matrix, I'm going to go over to the math section. And you'll notice the determinant comes up, right? And you can enter in a bunch of matrices. So I'm going to say I want the determinant. So, oh, you had to quit out, I'm sorry. Get your screen blank if it wasn't before. So second mode or second quit. Go back to matrix, over to math, I want a determinant. Now, how do I get matrix A to come up? I go back to the matrix button, right? And I can find the determinant of any of them I want, but I only have a matrix entered into A. So I can just go to A, hit enter, and there it is. The determinant is 55. The calculator does it all for you. But if it's just a 2 by 2, it's a lot faster to do it by hand. Okay, so let's move on. And this is the part that's review. Okay, and let me draw you a little picture here for just a second. Okay, we have 3 types of systems, right? When I say systems, I mean like systems of equations. They can either intersect, right, in one point. The systems can kind of be hidden. In other words, like, you know how 1/2 is the same as 2/4, they're just written differently, right? So they're kind of a hidden, in other words, they're the exact same line, they just look different. Okay, or the 2 lines I give you could be parallel. In other words, they'll never intersect at all. Okay, and this is the part that's kind of review. Now, which of these have no solution? Which ones, if I give you a systems of equation, which ones have no solution? The parallel lines, they never intersect. There's no ordered pair that works, right? Okay, which one has one solution? Obviously the one that intersects one time. And if they're the same line, then they have an infinite number of solutions, right? So we're gonna write about that in a second. So if you wrote those 3 lines out, that's a good job. Skip some space here, because we're going to fill in some information in this box in a second. We're going to come back to this. Okay? So the first set of information I'm going to give you, okay, the first systems of equations we're going to solve, and we are going to solve systems with Cramer's rule. Okay? So here's number 1. So if I told you 2x minus 3y equaled 9, and x plus 5y equaled negative 2, that is your systems. Now, I know we can solve them by elimination, I know we can solve them by substitution, but right now we're going to solve them with cramer's rule. And this, in order to solve them by cramer's rule, we're going to set up 2 matrices, okay? An XY matrix and a solutions matrix, okay? So let me show you what I'm talking about. So the first thing I'm going to do is I'm going to use the X coefficients. So it's a 2 and a 1, and they get their column. Then I'm going to use the Y coefficients, which is negative 3 and 5. They get their column. Okay, and you're going to close the matrix. Then you're going to set up a second matrix with the solutions. So the second matrix is just 9 and negative 2. I don't know if this is bringing back any memories or not, but. Okay? And our first step is to find the discriminant of this matrix. Okay, so let's do that first. So let's find the discriminant, the determinant, I'm sorry. Find the determinant. Okay, remember when you find the determinant, you're going to go this way first. So we're going to take 10 minus, you go the other way, negative 3. So the determinant's actually 13. Okay, and that's the first step, is looking at the determinant. Since the determinant was 13, okay, then that means it's going to qualify this systems right here that you just drew an equation for. This, okay, this is a set of lines, right? And since my determinant is 13, it means if you look at these different categories, it's this one. Okay, these systems just intersect in one spot. D, the determinant does not equal 0. They're just 2 plain old lines with just one solution. Okay, which means it's consistent. Okay, and has one solution. Has exactly one solution. Right, and that's what's going to go on here. So I'm going to show you how to find the answer. You ready? Okay, here we go. It's an ordered pair. We already decided that, right? So I know my answer is an ordered pair because that's what the answer to a systems is. It's a point, right? It's one point that makes both lines true. So I'm going to find x first. And to find x, what you do, okay, is you take your answer column and you change it out with the x value. So if I want to find x's, I replace my solution column for the x value. So I'm going to rewrite a matrix for me. And I'm going to make this matrix 9, negative 2, negative 3, 5. Okay? And I'm going to divide it by the determinant I already have. And really when you get to this part, we're going to find the determinant of this so you can take these brackets off. So the determinant of that. Okay, and we already found the determinant of we know the denominator is 13. So now we're going to do the same thing we did before. We're going to find the determinant of this x value, where we replace that with x. So it's going to be 45 minus, and you go the other way, a positive 6 over 13. Which gives us 45 minus 6 would be 39. So you have 39 over 13. I know, sorry. 39 over 13, which is 3. So the half our answer is 3. We know the x value is 3. Now let's find y. To find y, okay, you take the answer column and you plug it into the y's instead. So in other words, the x column stays the same, 2, 1, but because I'm finding y, I replace the y column with the answers, 9, negative 2. and the denominator is still 13. So now you're going to find the determinant again, which would be negative 4 minus 9 over 13. So negative 13 over 13 is negative 1. So 3, negative 1 is your solution. That's the point that intersects. Does that make sense? Okay. All right, so now let's do another one. So this time, guys, we're going to do one where the determinant is 0. Okay? So here's a different problem. 3x plus 5 equals 2y. 15 minus 6y equals negative 9x. What's wrong with this problem? Yeah, they're not in the right order, so clean it up, right? Let's just clean it up a little bit. We're gonna say 3x minus 2y equals negative 5, and 9x minus 6y equals negative 15. And we're gonna use that instead. Okay, so step 1 is to build your matrices you're going to use. So we're going to do 3, 9, negative 2, negative 6, and then negative 5, negative 15. And then you find the determinant for your XY matrix. Okay, so we go this way, the determinant of this matrix would be negative 18 minus negative 18. So what's the answer?
36.
0 minus negative 18. Right? 0. So go back to our little picture we drew a second ago. Go back to here. Right, so then this means that it's obviously not this situation, right? Because it says you can only qualify here if the determinant doesn't equal 0. Well, there are 2 problems that it does equal 0. We have 2 different problems. Either our answer is the same line, in other words, those 2 lines are the same, just look different, or they're parallel. Okay, and here's the rule. If D equals 0 and at least one numerator determinant is 0, then this is the situation. It's considered dependent. It has an infinite number of solutions. So in other words, we have 2 issues if D is 0. If D is 0, either A, it's the same exact line. In other words, and if that's true, the way you'll know it in this method is that at least one numerator determinant is 0. And if that's the case, it's obviously the same line, so it's dependent and it's infinite number of solutions. Okay, so let's see if that's the case on this one, right? So let's find x. Find x, remember we change these over. So we're gonna have negative 5, negative 15, negative 2, and negative 6, and we divide it by 0. So if you do the math there, it's gonna be 30 minus 30. Is that 0? Yeah, it's 0. 0 over 0, so we can stop automatically. Because if either one of the numerators, it doesn't require both, if either one of the numerator answers, either when you solve for x or you solve for y, if you get 0 in the numerator either time, then it's automatically is the same line. This is the same exact line. Okay, so they're considered dependent infinite number of solutions. That's what you would write. Okay? So we're gonna write dependent. It has an infinite number of solutions. Somebody asked me earlier if they could just write all real numbers. Because you can't write all real numbers. Think about a line, okay? If you have a line here, you only, let's see if you can see that. Okay, there we go. Dependent infinite number of solutions. If you have a line, the only answers that work are on the line, right? All real numbers don't work. This point, this point, this point, this point, those don't work, right? Lots and lots of answers work because the line keeps going this way and it keeps going this way forever. There's an infinite number of answers, but not every point works. There's a difference. Okay? All right, last problem of this type. And we have one more problem on the graph. Okay, here we go. Y minus 2 equals 3x. And then 3x minus y equals 7. First step would be put them correctly, right? Okay. You can tell by looking at this, these are all going to cancel. 0 doesn't equal 9, so that obviously the answer is no solution, right? Okay, but it didn't ask us to solve it that way. So it said to solve the cramers rule, so that's what we'll solve it as. First of all, let's set up your determinant, -3, 3, 1, -1, and 2, 7. You're going to find the determinant first. So you have 3 minus 3, which is 0. When you have a determinant of 0, you have two options. Either there's an infinite number of solutions, and if you look back at our picture, either when d equals 0, either there's an infinite number of solutions or they're parallel. If they're parallel, which that's what this is going to qualify as, okay? So if d equals 0 and neither determinant is 0, then it's considered inconsistent and no solution. So that's our last one. You see it? Okay, so let's finish solving it to prove it. So to find the x, I'm going to plug this in. So 2, 7, 1, -1. We know it's over 0. So you're going to have -2 minus 7. So -9 over 0. So that's not 0, right? The numerator has to be 0 at least one time in order for the line to be the same. If it's not either time, then they're parallel. So here's y. So put the answer column in for y. So -21 minus 6 over 0. Again, -27 over 0 doesn't work. So it's inconsistent. And no solution.